This next section is model data in Power BI. We will talk about the preferred format for your data to be in to be efficiently used by Power BI, which is the denormalized star schema. We will discuss relationships and the most common option of one-to-many or many-to-one. We will also focus on hierarchies and how you can enhance your visualizations and queries. Let's get started. Let's do an introduction to data modeling, and specifically an introduction to talking a bit more about some of the benefits and best practices involved with this process. The biggest benefit for data modeling is accurate reports along with using a denormalized star schema to get very fast query results. As a general rule, our best practice tip is to initially have a small and simple data model as possible. This diagram shows a denormalized star schema and also a snowflake, highlighted here in frosty blue. The sales table is the fact table that has numbers that we'd like to do math with, like amount and unit, along with foreign keys, product ID, store ID, and more to hold the many side of the relationship between the sales fact table and each dimension table. The table's calendar, customer, product, and store are all dimension tables. They hold the primary key, like date in the calendar table, customer ID in the customer table, product ID in the product table, and store ID in the store table, and the one side of the relationship with the sales fact table. Different dimension tables can be created based on how you would like to calculate the numbers in sales. For example, I'd like to look at the sales amount in the sales fact table by time or calendar, or maybe I want to look at it by customer or by product or store or region or by employee and more. Everything after the by would be a dimension table. Notice too that with each of the dimension tables there is a relationship between it and the fact sales table. Notice that the calendar has a relationship with sales, where calendar has the one side of the primary key and sales has the many side, where the asterisk is located for the foreign key. Notice too that the arrow is pointing from the calendar to the sales table, so we can query from calendar to sales. For example, I want to find out for September 1st what was our sales amount. Note too that the customer table, the product table, and the store table all have a direct relationship with the fact sales table. They are all points in our denormalized star schema. This schema is the fastest and most optimal for running queries. I want you to note too that we have two additional tables, association and associated product, and that both tables do not have a direct relationship with the sales table, but have to go through another table, product or customer, to be able to get to sales. This is a snowflake, which is normalized and isn't as fast or as optimal as the star schema for running queries, because it has a longer query propagation path to the fact sales table. We'll talk more about this in a bit. Let's talk a bit more on our fact and dimension tables. On this slide, we see the fact table on the left, fact reseller sales, and the dimension table, dim employee, on the right. Fact tables contain activities, observations, or events such as sales orders, stock balances, transactions, etc. The fact table usually contains a very large number of rows and will continue to grow exponentially over time. It also supports summarization, since it has the numbers like sales amounts, units, margin, etc., that you might want to summarize or use in calculations. It also contains the foreign key for each relationship that it has with the dimension table. Dimension tables describe business entities like products, people, places, and concepts, providing details or answers to questions like who, what, where, why, and how of our numbers. Dimension tables contain a relatively small number of records compared to the fact table and don't necessarily grow over time. The attributes or fields in the dimension table support filtering the fact table, like filtering the sales amount by employee or grouping the fact table by department. The dimension table has the primary key, or the one side of the relationship between it and the fact table, which has the foreign key and the many side of the relationship. Power BI provides the capability to establish relationships between tables from various data sources, such as enabling you to bring data together from Excel and relational databases into a cohesive semantic model. Let's explore how to create these relationships effectively. When connecting to a relational database, it's worth noting that relationships may already be defined by the database architect using primary and foreign keys. Power BI can automatically detect those relationships between the tables based on your data. You can leverage this feature and make necessary modifications or delete relationships as needed to align with your data model and analysis requirements. Relationships can be established using multiple columns within a table. By holding the Control key and selecting the desired columns, you can create relationships based on specific criteria. Here on the right, we see a relationship between the DIM employee table's employee key, that is the primary key, and has the one side of the relationship, with the fact reseller sales employee key, which has the many side or the foreign key. Notice too that the cross filter is pointing from the dimension table to the fact table to show the query propagation path. Each table can have only one active relationship, but it is possible to define multiple relationships between tables. On the left diagram, Manage Relationships, you can see the field Active and the checks next to the table that indicate an active relationship. Unlike other database management systems, Power BI has the concept of directionality to the relationship. This directionality plays an important role in filtering data between multiple tables. Cardinality in Power BI desktop relationships refers to the uniqueness of the data values in the column. It determines the relationship between tables based on the number of records that correlate between them. In this example, many to one cardinality, it means that there are multiple records in the left or top table that correspond to a single record in the right or bottom table. Many to one or one to many cardinality describes a relationship in which you have many instances of a value in one column that are related to one unique corresponding instance in another column. It describes the directionality between fact and dimension tables, which usually is a single cross-filter direction from the one side to the many side. It is the most common type of directionality and the Power BI default for automatically creating relationships. The other two relationships listed here, the one-to-one and the many-to-many, are both unusual cases of when you would use these relationships. Cross-filter direction determines the flow of data filtering between tables in relationship. This setting is normally set to single for most common relationships. Not shown here, but if the cross-filter direction is set to both between these tables, filtering can occur in both directions. This means that selecting a specific employee in the employees table will filter the fact reseller sales table to show only the sales data related to that employee. Similarly, selecting a specific sales record in the fact reseller sales table will filter the employee table to display only the relevant employee information. This is bidirectional cross-filtering, and it can create complex interactions which may result in unexpected or undesired filtering outcomes. It can also introduce performance issues. Use caution when using it. This is a great slide that shows in animated format how querying propagation works when querying using a single cross-filter direction from the one side to the many side. The category and product table represent a normalized snowflake. In this example, the query is asking for the sales quantity of category A in calendar year 2018. Note that it has to go first to the category table, which does not have a direct relationship with the fact sales table, and then query for category A in the products table to filter for products A and C. Then the year table has to filter the sales table, looking for calendar year 2018 in order to produce our result of 11. Hierarchies in Power BI allow you to organize and explore data in dimension tables by creating structured relationships between different levels of detail. They enable you to drill down into specific data points and gain insights into various levels of granularity. To create a hierarchy, access the data pane in Power BI Desktop and select the columns representing the levels of the hierarchy. Once the hierarchy is created, it can be used in visualizations. Consider a scenario where you want to analyze sales data by group, category, and region. By creating a hierarchy in the region dimension table, you can easily navigate through the different levels of the geography. This hierarchy will provide you with the flexibility to view data at a high level, such as total sales by region, and then drill down to country and city levels to gain more detailed insights. By leveraging hierarchies, you can easily navigate through different levels of data and gain insights at various levels of granularity. This enhances your ability to explore and analyze data effectively in Power BI. Now I'll show you a bit more about relationships and direct query in this next demo. Now I want to show a little bit about working with relationships, and I want to take it from a little bit of a different angle here by focusing in on doing it with direct query. So I'm starting right now in Power BI Desktop, and I have a blank canvas to work with, and I'm going to go up to Get Data, and I'm going to pull in some data from our SQL Server here. And I'm going to show direct query. So you may remember that direct query is usually used when you have a very large data source that changes frequently and where you'd like to have near real-time access to it so that you can display information as it changes here in our report and on our dashboards. We've already looked a little bit at import, where we can pull the data in to our Power BI PBIX file. Remember, this model size may be limited, of course, to your subscription. And if we decide to do an import, remember too that information is automatically going to be compressed and then put into cache. But direct query gives us a little bit of a different angle to approach this on. So I wanted to give you an idea of how this worked out too, as we also talk about relationships in this section. So I'm going to click OK to this. And I'm going to show us the data model again that we've been working with here, the database from SQL. I'm going to pick up our AdventureWorks DW 2022 here. And I'm going to use the fact table we used a little earlier called Fact Internet Sales. Remember, this is where we have our numbers that we'd like to crunch and do math with, along with our foreign keys that relate back to the dimension tables that we have. So I'm going to have it show me select related tables, and I'm going to remove a few tables from here, kind of just picking and choosing those tables that I'd like to have included, reducing the model size to just the tables that we would want to query from. I'm going to go ahead and load this into our data model, and it will take just a moment to do that. And when this is done, looks like it's here. You can see that it has some tables out here under data. I'm going to go to the model view and talk a little bit more about relationships. And I'm going to fit this to the screen so that we have a little bit of an easier look at all of the tables involved here. Now, what I'm going to do too is move these just around a little bit, and it can really show you the star here where you have the central fact table with our dimension tables around it, and then the relationships that they have. And notice I can set my mouse on each one of those, and let me make this just a little bit bigger maybe. We can set our mouse on each of those, and you can see where the relationship lies between the two tables. And there is one table here, our dim date table, that is a role-playing dimension table. You can see that it has about 3 relationships here with the fact internet sales table. And if we zoom in, you can see that there are a couple of the relationships in here that have the dotted lines, and one has the solid. So date key in the dim table, and let me drag this up a little bit, make it easier to see maybe. The date key has a relationship with the due date key field in fact internet sales. The date key also has a relationship with another field out here that might be a little bit lower, and it could be our order date field there. And then it has another relationship between the two tables, and this one I think is the maybe our due date. So actually maybe ship date right here. So you can see the relationships, and only one has a solid line. So dim date is a role-playing dimension because it has more than one relationship here, plays different roles with our fact internet sales. And any one of these, I'm going to find this one right here, this date key, I'm going to select it. I'm going to go into its properties, and you can see a little bit more about the relationship right here. So you can see the fact internet sales is up at top. So this is our first table, or our top table here. And this table right here has a field called order date key that has the foreign key. And then dim date has the this actually has our our primary key between the two. So the primary key for dim date is date key, and then the foreign key is in the fact internet sales table. And so since the fact table is up top, it's the many side, and the dim date table is second, it is the one side. So this is the many to one as it's listed here, but it's not an active relationship. So if I want to make it active, I can turn this button on right here. But as you can see, I get a little message here. And the message is that I already have really another active relationship. So it's hard for it to figure out which relationship to use. So only one relationship can be active at a time. So that means I really can't turn this on here. Notice I can't save it either. So I'm going to deselect that, and I'm going to cancel out of this. So if I wanted to change the relationship between these two tables from inactive to active, I can do that a couple different ways. I could go into manage relationships right here, and I can see the inactive ones that I have, and I can make those active if I'd like, and it would turn the other one to be inactive. So only one relationship between the two tables can be active at any one point in time. The other way to do this is I can use DAX, and DAX has a function called use relationship, and I can do that too to tell it to use an inactive relationship. So you can work with these if you like, but keep in mind that this is not the optimal design between two tables like date and fact. The idea here is that instead of having dim date do role-playing dimension, have 3 different relationships with your fact internet sales, the better way to do this is to take dim date and have it broken out into 3 separate tables. One for the ship date, one for the order date, one for the due date. That would be the better way to do this, because having to make the relationship active or having to use that use relationship in DAX would have to be done before I could do a calculation using the inactive relationship. So it just adds an extra layer of things you have to do. So better to break this out. But this isn't a very uncommon way to lay this out. Role-playing dimensions are used quite a lot, but it's not the optimal option here for working with DAX, and in particular with Power BI and relationships. Your better bet is to break it out. So I want you to also notice that as we brought these tables in, they all have these blue bands, and that's because they are set with direct query. So what I want to do is I'd like to bring in another table. So I'm going to go back into my Get Data with SQL Server here. I'm going to paste back in to get to my SQL Server. And this time what I'm going to do is I'm going to import in a table. And I forgot to bring a table in that I'm going to go ahead and pull in right now. And that is our currency table. I'm going to bring in dim currency. So if I forget to add, I can always, I'm going to load it this time rather than going into transforming, and I'm going to import it also. So when I do that, notice it's refreshing the other tables that I have, but it's also going to add dim currency. And you can see the difference between dim currency and the other tables. It doesn't have that blue bar, and that is because we imported as opposed to letting it be another option here with that direct query option. So this one you can see the direct query. You can get some more information here. It was imported in. So what I can do right now is simply create a relationship between it and the fact internet sales table. So I'm going to choose the currency key in dim currency, and then I'm going to see if I can find it in here. And they should be alphabetized. There's the currency key. So I'm just going to drag it from dim currency key down to the fact internet sales currency key. And when I do that, I want to check the relationship. So the dim currency is the one side, and the fact internet sales is the many side, and it's going to be an active relationship. And right here you can see it's going to be a single directional cross filter. There is an option to choose both, but those are usually special scenarios, maybe in a one-to-one or a many-to-many relationship. You might find those used. But what I'm going to do is I'm going to go ahead and click Save here. And that should set up our relationship for us. So you can see the relationships. You can see how they're formed between the two. You can see the cross filter there going from the one side of the dimension table's primary key to the many side of the fact table's foreign key. And relationships can be built here in your model. You can build it out in maybe a SQL or in a data warehouse in Fabric. And you could create your denormalized star schema, which this is a representation of. So there's a lot to working with relationships. This is kind of the tip of the iceberg, but hopefully enough to get you going in the right direction. Thank you so much for joining me in this section, and I hope to see you in the next one coming up. You may want to complete the Design a Data Model in Power BI Desktop Lab. This is the lab where you develop your data model by creating relationships between our tables and then configure a table and column properties to help improve its usability in the data model. Remember that you have access to the lab steps and the lab files in GitHub. You also don't have to complete the previous lab in order to do this lab. Now it's time for our data model knowledge check. Question 1. What is the difference between a fact table and a dimension table? Answer. Fact tables contain observational data, while dimension tables contain information about specific entities within the data. Question 2. How do you describe a star schema? Answer. Multiple dimension tables with relationships to one fact table. To recap this section, we covered the denormalized star schema along with the fact table and dimension tables and the cross filters and the relationships between the tables. Remember that the dimension table has a primary key and the one side of the relationship, with the fact table's foreign key or many side. Remember too that queries can be auto-created from your data or manually added, whichever you need. The most common type of relationship is the one-to-many or many-to-one. Use hierarchies as they will enhance your queries and your visualizations as you drill down from year to quarter to month to week to day to hour to minute to second, as an example, in your data. Looking for sales amount by calendar.